So that error comes from a mismatch between the version of QGIS and the version of Python that are on the virtual machine. Unfortunately, I do not have administrator access to that, so I can't reconfigure it. However, I think that it's only that one step, that step of defining the regions of interest that is broken. I think that's the only step that uses these two mismatched tools. So I'm going to go ahead and do that step on my personal machine, and I'll make that file available for you. And if you are using this on the virtual machine, hopefully you'll be able to just watch this step and then follow along. I'm going to test that, and if it's really broken on the virtual machine, that's a bummer. But the main point here is to sort of understand what's happening. So if you watch and even without the ability to follow along, you'll get a pretty good sense of what's going on, and you'll be well equipped to tackle the somewhat expansive quiz questions this week. So we are going to define a training input. Create a new one. Oh, look, there already is one. Okay, we'll just overwrite that existing one. Yes. Okay. And then we were just talking about creating these regions of interest. So to start with, I'm just going to create, you can see this got all messed up. For this macro category 1, which is forest, I'm going to create a big old polygon of forest things. Just pretty arbitrary here, but that ought to contain a good variety of things that are within those, those 5 different forest categories in the NLCD. So I'm going to click Save, and it's going to take a couple minutes here. Well, not a couple minutes. It's going to take a minute or two. I'm not just saving the shape to a file. That would only take a couple seconds. It's actually crawling through and looking at all of these different bands and trying to understand the spectral signature that's associated with this area in those bands. And it does that because it's going to distinguish between areas of this forest type and areas of other types based on that spectral signature. And spectral signature is just a fancy way of saying, what colors are there for visible spectra, or, what is the distribution of data? What's the max, what's the min, what's the average, what's the range for non-visible data. Okay, so we can create more of these manual polygons. You see I'm trying to get a little bit close to the edges here. And then right click to finish it, save that. In an ideal world, we would create a ton of these training regions of interest, tens or hundreds. You can see it takes a while, though, to create them. So if you're working on a slower computer right now, if it's, really taken quite a while to calculate the signatures for these regions, I would say 3 is probably the minimum that you need for each category. So try to create that many at least, such that the algorithm sort of works. And then know in the future, the more of these regions you can create, the better you can train the algorithm. And so you do want to spend some time doing it. And again, like I mentioned, you can do this directly from vector data. So that's the rectangle, the manual polygon, I should say. They aren't rectangles, way of doing it. But there's another fancy way of doing it in which we use this button, the region of interest pointer. And then I'm just going to click in one point, and it is going to identify an area that is similar to that point that I clicked. And so if I look at that, it looks like it identified I mean, this must be the river. This must be the black being not forest. That must be the open water. It identified that as different than river, but it was a little bit, at least, I don't want to say absolutely wrong, but it differed a little bit from what the NLCD dataset thinks about forest up here. So in that particular case where I clicked right there, I'm not super happy with the region that it calculated, but there's a lot of tools I can play with here. There's this distance. This is not a literal distance. This is how much difference the tool considers when it's, how much diversity the tool allows when it's creating its region. So maybe if I turn that down 2 clicks, I have no idea what the actual meaning of that number is. I'm sure it's a coefficient of some some algorithm that I don't understand. But hey, I don't need to. So I turned that down a little bit, and I clicked, and so it did quite a bit better there. It still got some forest in, so I'm going to turn it down one more click. Okay, that's just a tiny area. No real point in doing that. Let's just keep clicking around until we find what it includes. There we go. That's a good one. So that includes quite a lot of forest and almost no not forest at all. So I'm going to save that one. So by playing with that distance, and then you can also play with the minimum size. This is, how small the area is allowed to be, and then the maximum size, both in units of pixels. By playing with those, you can sort of help it to create these training regions of interest pretty efficiently. I say that as the computer is taking its sweet time calculating the signature for that area. So run through one or two more of these here. I would not recommend turning up the max area very much unless you're working on a super fast computer. If you do turn up the max area, you can expect to wait quite a while the computer calculates the region. Okay, so that one I don't particularly like. It includes a little bit more forest there. I could play with it. I could turn this minimum down, say 10, and then turn this distance down so we're being really picky and try to get some of these small pockets of forest. Let's see if we can get something in there. Yeah, so we clearly identified a small piece of forest there. We'll go ahead and save that guy. Again, if you were trying to do this, as best you possibly could, you would spend a lot of time identifying these areas. And also, you might think about more than just the land cover data set. Our simplistic goal here is just to extend the land cover data set. So all we're trying to do is come up with training polygons that mimic the land cover data set. And we're not expecting it to be perfect at all. Let's see if we can get a couple slightly bigger ones. Yeah, so that's pretty good. Follows that crescent shape. Go ahead and save that guy. If you are able to get this to work on your computer and it runs at a reasonable speed, you can play around with it and you can get pretty good at it. You can see that I've messed around with it enough to sort of know what I'm doing here, but I'm definitely not an expert. So this will get me 5 in the forest category once this one finishes. And I'm going to do 3 categories total. I'm going to do forest, I'm going to do water, and then I'm going to do everything else. And So if I decide 5 is good enough for the forest category, in reality, you know, 10 would be all right, 50 would be great, 1,000 would be pretty nice, but I don't really want to sit here all day doing this. So let's jump to the next category, and let's do water as the next category. So I'm going to turn off this, oops, not that layer. I'm going to turn off this is forest layer, and turn on the is water layer. So white is water and black is not water. Simple enough. So we're going to need to turn the minimum area down pretty far. And let's see how we do here. Oh, that did not work at all. So let's turn that distance down. Yeah, that maybe worked. I'm not super convinced. One other interesting thing, yeah, that didn't work at all. One other interesting thing that we see here, oh, let's try a lake. That's a good way to get some water. One interesting thing that we see here, I bet I can turn that up a little bit, that the pixels that we're classifying, nope, actually don't align perfectly with the NLCD pixels. You can see there's a little bit of overlap there. You know, like the sort of stair-step edge of the NLCD pixels is aligned differently than the stair-step edge of these regions of interest that we're identifying. That's because the regions of interest relate to the Landsat data, and there's no reason for the Landsat pixels and the NLCD pixels to be in the same alignment. So I like that one because it seemed to capture the edge of the lake there reasonably well. So I'm going to do 5 in each class. So I'm going to do 4 more in the water class, and then I will also do, I'll go ahead and pause the video while I fill up the water class here. All right, so I've created a number of training shapes in the water category. Now I'm going to create a couple in the everything else category. That is land use that is not, or land cover that is not water. So let's turn back on the is forest layer, turn off the water layer. And so now I'm going to be trying to click on the black areas, but I'm going to avoid the stream itself. It's pretty obvious what the stream channel is here. And firstly, I need to give this a new macro category ID and a new name. So this, we'll call this other land. And start clicking here. So white is forest, black is anything that is not forest. I probably can turn my distance up a little bit here. I had that distance down real tight when I was classifying the water. Because this is the everything else category, I do want to try to get a number of points. I mean, there's so much that could be everything else, like bare rock and snow, the developed areas. There's quite a lot here. So again, if I was really going to do this classification as best I could, I would spend quite a while making sure I'm like creating enough training polygons that I'm fully characterizing this everything else category. So I'm going to click around and create these polygons. You can see I prefer the automatic tool. Let's turn this distance, turn this distance up a bit. That'll make it a little less sensitive. You can see I like this this automatic tool more than the manual draw rectangle tool. Neither is ultimately better than the other. That's definitely not catching the difference between forest and not forest, at least as mapped on NLCD. Not so much right there. Let's see if we can get a good one somewhere. Oh, that one's pretty small. Also pretty small. I think there's just so much diversity in this not forest class. Yeah, see, that got some of the edges, but it also got quite a bit that is forest. There's just so much diversity in this class that the automatic tool's having a little bit of trouble. So I'm going to create a couple of manual polygons here. Again, not trying to be perfect, just trying to give enough of an idea that we have something interesting to look at. Okay, go ahead and save that guy. Okay, I'm going to pause the video while I create a couple more of these polygons, and then we'll see how the classification looks. So I've defined a handful of the other land area polygons, regions of interest, and now I'm back on the virtual machine, and I think I'm gonna be able to open that definition file and have it work from here. If you are working on the virtual machine, I will post this definition file. Oops, not create a new, wrong button. Open a training input. It will be forestwaterother.scp. I'll post that on D2L. And if you're working on your own computer, hopefully you don't have this particular issue and you can just keep working straight through. So I'm going to collapse these categories. Again, we're only interested in not the master categories. What are they called? Meta categories. Macro categories. That's what they're called. We're only interested in those. We're not interested in the difference between the subcategories. So let's give these some logical colors here. We'll make forest nice and green. Okay. Let's make water bluish. Okay. And other, we'll just go with a dark tannish color, orangish color. So one more thing we need to do. We got to get the main plugin window open. Clicking any of those buttons over there brings it open. Get over here to the band processing and here to the classification tab. And okay, it's set up right. We want to make sure we're classifying based on this macro category ID. We could just flip this back and forth. If we did the category ID, that wouldn't have a whole lot of meaning right now because each of the individual regions of interest is a category within the macro category, and there's not a lot of meaningful difference between them. Okay, so that's set up right. So I am going to make that a little smaller. I'm going to click this preview button here. Oh, I guess it already was clicked. Click it again so it's back on. And then this button right next to it says classification preview pointer. So remember, in this underlying map that I'm looking at right now, white is forest and black is everything else. So I'm just going to click here and then be patient for just a minute. And if it works, there we go. So we got green being forest, the rust color being other, and then we've got blue as water. So it actually looks like it did water incredibly well. It's getting the general pattern. I can turn this layer off and on to compare it. It's definitely getting the general pattern between forest and not forest. There's maybe some details that it's not getting. On the other hand, the NLCD data is far from perfect. There's definitely a couple of errant trees in unforested area, according to NLCD. In fact, I think if you look at the definition of the forest classes, they specifically state that they're areas that are more than 20% tree canopy cover. So, hey, I don't even know that this is wrong at all. In fact, it honestly looks pretty good to me. Try another spot down here. So this is just a preview. I'm just getting these sort of quick tiles. It's nice to look at these to decide whether you think your classification is good or not before you apply it to the whole area. So again, it seems to be a little bit conservative about forest. It's finding a lot of not forest within the forest. I don't know that that's wrong though. If I compare it, yeah, that's pretty good actually. It's definitely getting the overall picture pretty good. Let's look at it in a heavily forested area. So there should be, oh sorry, heavily not forested area. All this black and white is confusing. Yeah, pretty good. It's finding a couple trees in there. Who knows if they're there or not. Yeah, really not bad. So the real strength of this, right now, this raster, this is the extent of the NLCD, but I'm not limited by that anymore because I'm building this off of the satellite data, and the satellite tile, wherever did they all go? Nope. They're there. The satellite tiles, remember, they, if I can succeed in displaying them, these satellite tiles extend further. So this right here is the US-Canadian border. This is the extent of the NLCD data. But the satellite data extends further north than that because because the satellite doesn't respect political boundaries. So I can click up here, and since I'm within the region of the satellite data, it doesn't matter that I'm beyond the spatial extent of the NLCD. And so that's the whole point of this exercise, is that we can now, we might not have the best land cover classification model that could be built, but it's honestly pretty decent. And we can extend it beyond that national boundary. We're no longer constrained by the extent of that data set. So in a sense, we've just built a tool for extrapolating this really simplified NLCD-based classification. So one more fun thing I want to do, let me turn off a bunch of stuff, turn off NLCD. And I want to add a, how do I do this? Again, working in the virtual machine, so you can count on everything being poorly set up. Once I get all these layers, okay. Oh, and QGIS just crashed, okay. What I want to do is compare the model output to some higher resolution satellite data, just like the normal Google satellite image. We'll see if I succeed in doing that on the virtual machine or not. Okay, we're back. Turn that off. Did I succeed? There we go. I did succeed in getting some other things up here. So let's just turn on Google Satellite, And now let's keep playing with the preview tool. It can be pretty interesting to see where the previews or where the classification model is right and where it's wrong. You know, like I wonder if it's going to capture this. Is it working? Oh, I have to, because I reloaded Q, I have to reload my my signature file. There it is. Okay, if I save the project, that probably won't happen again. Okay. So I'm curious if it captures that little unforested area. Oh, I lost my colors too. Oh, yeah, okay. We gotta clean that up a little bit. Computer, you should know these things. Forests are green, water is blue, and other things are some other color. Okay. Try this again. So if I turn this layer off and on to compare it to the satellite image, yeah, it's not bad. I would say the forest cover is a little bit more complete than the model is showing. But on the other hand, you know, if I zoom in here, there's this house here, and it's identifying spotty forest cover over there. So yeah, really, really not bad at all. That's going to be an interesting one. I think this is super cool. I hope you guys think it's at least halfway cool. Yeah, it seems like it's underestimating forest right here. So if we wanted to keep going with this, we would identify this as a case where the maybe we have insufficient training data, and so we could, you know, we could manually identify a forest piece right in here to try to teach the algorithm that no, that is actually forest. So not perfect, but it works. It is always a little bit interesting to sort of extrapolate way beyond the bounds. I've been extrapolating beyond the spatial bounds. That's the point of this exercise, but that's worked pretty well because the river valley in Canada is not that different than the river valley in the US. If we go up here, for example, I haven't done a lot of training polygons, not deliberately anyway, up in the alpine areas. Absolutely no idea what it's going to come up with. Yeah, thinks the whole thing's water. So it actually got the forest pretty well. But interestingly, it thinks a lot of these steeper slopes are water. Some of them are snow, so maybe it's picking up that right. Anyway, fun to play with. That's the end of the tutorial video. As you'll see in the text, the assignment for this week is simply to follow along through this exercise and look at the quiz questions, which are just intended to get you thinking and hopefully not to slow you down too much. As usual, the goal here is education, maximize the education and minimize the frustration. But you've certainly seen me struggle. I have this massive error with the virtual machine that I'm incapable of fixing. And if you guys run into some sort of incomprehensible error along the way, firstly, let me know. I'll try to help you figure it out. May or may not be possible. Especially using a plugin, we've moved pretty far beyond the core capabilities of QGIS at this point. So if it's an error that's not fixable, or at least not fixable in the time scale that we have at the moment, then the idea behind this module, I can't resist clicking more while I'm talking. The idea behind this module is that just by following along through these tutorial videos, you can get all of the insight that you need to succeed here. So yeah, that's it for the tutorial videos. I look forward to hearing a little bit more about your projects. Please feel free. I know everyone's going in a different direction, but please feel free to hit me up with some questions there as well. I hope this material has been useful for you developing your projects, and there's going to be a couple more tidbits coming up in the next couple weeks that should help you along the way. All right, signing off for this module. Thanks for watching.